guys that are at home, this worksheet is posted in the Schoology folder. Make sure you're looking at the side that says Notes, and try 1A as a warm-up. Left Riemann Sum, and give it a try, then we'll go over it. What I usually do with these is sort of make a graph, like view this as like a rectangle. Let's see, 5.7, 5.2, 5.2, 4.1. So kind of a graph, but no, don't make it a full graph. Just kind of make it a graph right above that. And so I can immediately see how wide that graph is. And then I can decide if I want to use the left hand, if I want to use the left hand numbers or if I want to use the right hand numbers. So that sort of answer your question. So I don't want to make a full graph. I kind of want to make a graph. And I guess I should be careful because if that's 2.8, what I'm drawing is what I've been drawing there is the left-hand rectangles, which is what we want for this one, but that would make part B a little bit tricky. So use the left-hand value and the width times the left-hand value, and add them all up. All right, so let's go over these. A left Riemann sum means I want to use the left-hand side of the interval. So this first interval is 20 wide, and if I want to use the left-hand height, it'll be 20 times 2.3. That's the first interval, or the first rectangle. The second rectangle is also 20 wide, from 20 to 40. And I'll use the left-hand side, so 2.8 high. And then the third rectangle, 40 to 60, is 20 wide. And I'll use the left-hand height, so 4.3 high. And I'm running out of colors. I think I got a blue up here somewhere. The fourth rectangle, 60 to 80, is also 20 wide. And I'll use the left-hand height for him, 5.7. And now I'm just going to switch to not using colors anymore, but the next rectangle is 80 to 100, is 20 wide. The left-hand height is 5.2. And the last rectangle is 20 wide, and the left-hand height is 5.2. I never used 4.1. Is that okay? I got one thumbs up and a bunch of blank stares. You're right. It's okay. The 4.1 we'll use when we come from the right. Now that's an okay final answer. So I don't have the key with me. If you want a different answer, then type it all in and see what you get. I'm just going to leave it like that. For a right Riemann sum, so same kind of thing. My picture is now a little bit tricky because those are all left-hand rectangles that I drew. But my first rectangle is 20 wide still, but I want to use the right-hand height. So I'm going to use the 2.8. Now this gets a little tricky if you wanted to draw them both, because now you'd have this triangle, or that rectangle, as your right-hand triangle. The next one is still 20 wide, but I'll use the right-hand height, 4.3. The next one is 20 wide. The right-hand height is 5.7. The next one is 20 wide. I need three hands here to point to everything or keep track of where I am. And the right-hand height is 5.2. The next rectangle is 20 wide, and the right-hand height is 5.2. And then the last rectangle is 20 wide, but the right-hand height is 4.1. So that time I used all the right-hand heights. I didn't use the 2.3 anywhere, but that's okay. That was a left-handed thing. Nick?
Can you start with like like 20 times 4.1?
Sure. So if it makes sense to you, if you're doing a right-hand sum, and you want to say, well, I'm just going to go ahead and start at the right and work sort of backwards, you can do that. Yeah. And if that makes more sense to start over here and say that's 20 wide, and I'll use the 4.1, so you'd have exactly the same turns, they'd just be in reverse order. I don't even want to say backwards because that implies that it's wrong. It's not. It's fine. So I don't. Was it this class that we wrote it? I think it was a different class yesterday. We did that. We wrote one of them backwards because someone had the same idea. Well, can we just start at the other end and work that way? And the answer is yes. Yes, you may. All right. The next one is midpoint and trapezoid. So let's set this aside. We'll get to those later. Let's talk about midpoint and trapezoid rules. A little bit of notes, and then we'll jump over back to the worksheet and do some more of it together. So first, the midpoint rule. So we'll use the height of the rectangle. Well, let's rephrase this. We'll get the height of the rectangle using not the left hand x value or the right hand x value, but using midpoint of the subinterval. Let's do a problem with a graph that goes with it, more like yesterday rather than the table that we just did. So let's use the midpoint rule to estimate the area under y equals x squared plus 2 on -1 to 3 with 4 subintervals. Okay, well, let's draw the picture of the parabola on 1 to 3, shade in the area so we at least know what we're approximating here. Okay, x squared plus 2. I want to make my x intervals kind of wide because I'm going to need to use the midpoint of them as well. So let's see, x squared plus 2, that's the standard parabola shifted up 2. If I plug in 0, I'd be at 2. Plug in 1, let's see, 1 squared plus 2 would get me to 3. Same thing with -1. I plug in 2, 2 squared is 4, plus 2 is 6. 1, 2, 3, 4, 5, 6. I plug in 3, 3 squared is 9, plus 2 is 11. 6, 7, 8, 9, 10, 11. Oh, poor planning. That's all right. So there's my picture. I want that area from -1 to 3. Yesterday we lightly shaded it gray, if that doesn't mess up the rest of your notes, because we're going to draw rectangles in there in a minute. So that's the area we want to approximate, estimate. And we'll do it with the rectangles. So we can kind of start the same way. The width of each rectangle is going to be 1. So that's kind of nice when we have a evenly spaced or nice. So there's my 4 sub areas, I guess, that will approximate with rectangles. But we're going to do the area, we're going to approximate it with midpoint rectangles. So I'm going to get the height of my rectangle. So this first rectangle, just call that one rectangle A. So again, we're just adding rectangles still. So this isn't, I mean, it's more complicated than yesterday, but we're still adding rectangles. So I want to get the height of that rectangle. Well, let's back up. The width of the rectangle is 1, so that's the easy part. Go in the same order we did yesterday. The width times the height. But I'm going to get the height now, not at the left end or at the right end. That would be a left sum or a right sum. But I'm going to do a midpoint sum. So at negative 0.5, I'm going to use that rectangle. So that would be the function at negative 0.5. We'll go back later and figure out what that is. So that's rectangle A. Rectangle B, same thing. I don't want the left-hand rectangle like we did yesterday or the right-hand rectangle. I want the midpoint rectangle. So at 0.5, I need the height at 0.5. So my width is still 1, my rectangle is 1 wide, and the height I'm going to use is the y value at 0.5, at the midpoint. I don't know, this already seems like it's going to be a better approximation than the left or the right, because some of the rectangle is, inside, some of it's outside, so this is probably a pretty good approximation. Rectangle B. Rectangle C is still 1 wide. And I want to find the height at the midpoint, or use the height at the midpoint. So that would be 1.5. So the height at 1.5, the y value at 1.5, f of 1.5. And then the last one, rectangle D, the height at 2.5. So again, the width is 1, and I'll use the y value at 2.5 for rectangle D. Still adding rectangles, a little bit more complicated because I'm not using the left or the right, I'm using the height at the middle. Now I need to clean this up a little bit and figure out what all this is. Let's see, f of negative 0.5 would be 0.5 squared plus 2. F of 0.5 would again be 0.5 squared plus 2. Again, we had this yesterday, this 1 times out front. You don't have to leave it there, but I'm leaving it there to remind me that I'm still adding up rectangles, and this is still base times height, base times height, base times height. 1.5 squared plus 2, and then 2.5 squared plus 2. And that's a safe stop. Like I don't know what that is. I'm fine with that. but somehow I can't help but give the answer. It just feels incomplete, although we need to be okay with leaving it like that. So that's a midpoint rule. Tell you what, let's jump over while we're thinking about midpoints. Let's go back to the worksheet and do 1C. So back to the worksheet. Again, you're on the notes side. Be able to keep it straight now because that's the side we've been working on. Read C very, very carefully. So obviously it says midpoint sum. How many intervals? 3. Do you know why we're doing 3 intervals instead of 6 intervals? Because we're doing the midpoint of each one. That's a good answer. If I want the midpoint height between 0 and 20, I don't know what it is. Right? So it couldn't ask me to do a midpoint sum with 6 intervals because I don't know the height at 10. So my midpoint sum with 3 intervals, maybe I could draw it on the bottom here. So there's going to be 1 interval, 2 intervals, 3 intervals. This is my sort of my midpoint work here. So how wide is that first interval? How wide is this interval? 40. I heard somebody say 40. Does that make sense? It goes from 0 to 40, so it's 40 wide. Now I can use the left hand, I could use the right hand, or I could use the midpoint height, but it told me to use the midpoint height. So 2.8, because 2.8 would be the midpoint height of that interval. Now you should have 2 more rectangles. See if you can figure out what the 2 more rectangles are. Nick, tell me how wide is that next interval?
40.
40. Somebody else tell me what height we'll use for that interval. 5.7. We'll need to use the midpoint height. And then that last interval, how wide is that interval? 40. And what height should we use for it? 5.2, the midpoint height. And then, again, safe stop, we can leave that as our answer. It might be helpful to calculate them all and see which one, but they're all estimates, so we wouldn't really even know which one is accurate or not. So midpoint it's the same thing. I mean, just add up the rectangles, but use the height at the midpoint rather than the height at the left or at the right. All right, back to notes. Let's do trapezoids. Feels like trapezoids might be our best bet for getting an accurate estimation of the area. Now I'm going to draw a trapezoid unlike the ones that we usually draw. I'm going to draw it like the ones we will see. All right, that's the trapezoids that we will use when we're adding up area. All right, like the trapezoids from elementary school. Like, they all look like that, right? Like, that was the only trapezoid you saw in elementary school, I feel like. Now we're tweaking things a little bit. This is still a trapezoid. The area of a trapezoid. Let's see. Let's use some of the same. I'm going to call it. What do you want to call this dimension here? Is that the width? Is that the base? You can call it either one. I'm going to call it the width. Sorry. If you want to call it the base, call it the base. It's fine. So our area of a trapezoid is width times. I guess we're going to call these the heights. But there's 2 different heights. So it's the width times the average height. This is sort of backing up to the how do you find the area of a trapezoid in geometry. Width times the average height. The average height is add the two heights and divide by 2. And so that's how we'll find the area of a trapezoid. You might recognize that as it's basically the average of the left-hand sum and the right-hand sum, because the left-hand rectangle would be H1, the right-hand rectangle would be H2. If we take the average of the two, we get the trapezoid. So let's estimate the area under, let's do the same shape. Y equals x squared plus 2 on -1 to 3 with 4 subintervals. It's not 4 rectangles now, it's 4 trapezoids. So I'm going to draw the picture again. This time I know I need to get to 11. I should have planned that out better last time. So 0 we were at 2, -1 we were at 3, 2 we were at 6, and 3 we were up at 11. Again, I don't know that you need to lightly shade, but if it helps you see, that's the actual area. We will approximate that with a trapezoid, or with 4 trapezoids. So, trapezoid A. It's hard to sketch that in there. So what we called the width is 1, and then we need the average of the two heights. So I guess you could find them, but I'm going to do it as function notation here. So there's trapezoid A. The width times the average height. Stick with the same color scheme here. The next one we'll go with green, call that trapezoid B. So width is 1, and it's the average of those two heights, f of 0, f of 1. You could just tell from the picture that this is going to be a really good approximation. Trapezoid C, width is 1, average of the two heights, f of 1 plus f of 2 all over 2. Trapezoid C. I'm almost out of room for trapezoid D, but that's the idea. 1 wide, f of 2 plus f of 3 all over 2. Now, we're not quite done because we need to evaluate the functions. It's not a safe stop yet. We need to find what those functions are. But I want to do a little bit of what the book does so that if you're ever looking, you'll understand maybe a little bit of what's happening here. All of the widths are 1, so we can take the 1 out. We're dividing them all by 2, so I'm going to take that 2 out. So the 1s are gone, the 2s are gone. Well, it's not gone, I shouldn't say that. The 2 is out front now. And look what's left. F of negative 1 plus, how many F of zeros are there? There's 2 of them. And there's 2 F of 1s. And there's 2 F of 2s. But there's only 1 F of 3. This is sort of how books always, they sort of jump to this when they do the trapezoid rule. And unless you understand where it came from, you're like, well, why are there 2 of some of them and only 1 of the endpoints? Well, it's because that endpoint height, those endpoints, their height was only used once. They're only in one trapezoid. All the other heights are part of 2 trapezoids, right? The interior heights belong to trapezoid A and B, or B and C, or C and D. So the interior heights get used twice, the end heights only get used once. Some people will sort of memorize this as a trapezoid formula. I think most people are better off just saying, you know what, we don't use this often enough to memorize the formula. Just add up the area of the trapezoids. I think that's the best way to go. So let's see, that would be 3 plus 2 times 2 plus 2 times 3 plus 2 times 6. You can just trust me on this, plus 11, or you can plug them in, whatever. And so that area turned out to be 18. Our previous approximation was 17, so that's pretty good. I'm now curious what the actual area is. We don't know how to find the actual area yet. We'll get there. Negative 1 to 3 of x squared plus 2. But the actual area is 17 and a third. So you just kind of have to trust me on that. The actual area is 17 and a third. So it actually turned out that the midpoint rule was better than even the trapezoid rule was, but we don't really know that yet, or how to figure that out yet. So questions on trapezoids? Like, don't get lost in the how do I know if there's 1 of them or 2 of them. Like just add up the trapezoids. That's all you need to do. All right, we'll flip back to our worksheet page. 1D. Estimate that. You know what? We hadn't talked about what that means. Guess we should do that. If you haven't figured it out, it's the area under F from 0 to 120. Using a trapezoid sum with 3 subintervals. Okay, that's good news. There's enough information there to do 6 subintervals. They're just taking it easy on you. So the first subinterval, I kind of have the subinterval set up. I don't want to use those height, but I will use that subinterval. How wide is that first subinterval going to be? 40. But then I need to use the average of 2 heights. So which height am I going to use? Yeah, the end heights. I'll take the average of 2.3 and 4.3. That's my first trapezoid. Second trapezoid goes from 40 to 80, so that's 40 wide as well. And again, I'll use the two endpoint heights. 4.3 plus 5.2 all over 2. Because I want the average height based off the two endpoint heights. And then the last one, 80 to 120, so that's 40 wide. Again, the average of the endpoint heights. 5.2 plus 4.1 all over 2. And safe stop that. Like, I don't want to mess with that. And so we've got 4 answers that all approximate the area under that curve. And since all we have is points rather than the actual area, we don't know which one of those estimates is the most accurate anyway. All right, let's work through. Let's work through number 2 together. Basically, your assignment today is finish this worksheet. We'll just see how far we get together. So number 2, the rate at which water flows into a pond in gallons per hour is given by a differentiable function r of time t. That's a lot of words there. I don't know if we need to make sense of them or not. The table below shows the rate as measured every 4 hours for a 24-hour time period. Actually, that's not quite right, is it? It's measured every so often. How about we just... Right? Because it's not every 4 hours. They changed it up on us. We measured it every however long they got around to it. And we want to estimate basically the area under the curve. So exactly what it means, we're not sure yet. We'll get to that later, although R is in gallons per hour. T is in hours. So our answer will be gallons. Right? If we multiply hours times gallons per hour, we'll get gallons. But that's units, and that's not really what we're concerned with yet. Left Riemann sum with 6 subintervals. Okay, be careful. This is the first time we've seen one that doesn't have the intervals aren't equally spaced. So how wide is my first rectangle? And what height will I use? 6.2. So we got to be real careful here. So it's 5 wide, but I'm using 6.2. How wide is the next rectangle? 4. And which y value will I use? 7.1, because I'm using a left-hand sum. How wide is the next one? And which y value will I use? 9.3. And how wide is the next one? 4. And again, I'll use the left-hand value. And then the next one is 6. And I'll use the left-hand value. And the next one is 3. And I'll use the left-hand value. And then I should go back and make sure that I indeed have 6 rectangles. 1, 2, 3, 4, 5, 6. And safe stop, you can leave it at that. Right-hand sum, I'm hesitant to even write it because I bet half of you are going to be writing it from the right and half of you are going to write it from the left. Either one's fine. If it makes sense to start at the right, then that's fine. You'd say it's 3 wide and we'll use that one, and then 6 wide and use that one, and so on. I'm used to writing it from the left, so I'm going to write it from the left. let's mark out the bottom two on this side. There is the bottom two on the back side that you need to practice on, but we don't need to practice 4 of them. I think 2 of them would be fine. And I guess I'll go ahead and write the trapezoid, and you can look up here if you wanna check. But we're kind of done. Your assignment is finish the back side. And if I don't have answers posted, I'll post them eventually.